Hi and welcome back. This video segment is going to be discussing direct and inverse variation. First, we're going to talk about direct variation. And as you might recall, that stated that as one value increases, the related value increases. And as one value decreases, the other value is also going to decrease. And we related this to wages. The more hours you work, the more money you make. They both go up. If your number of hours decreases, the amount of money in your paycheck decreases. And we're going to see this written y varies directly as x, or x varies directly as y. And as a reminder, we discussed our equation y equals kx, where k is the constant of proportionality. All right, let's look at an example. Here we're given some values, some x and y values, and we're going to need to determine if indeed it is a direct variation, and if so, what is that constant of proportionality? So we're going to use our equation y equals kx to find out what that constant is, and to do that we're going to substitute an ordered pair into the equation. And if we remember, an ordered pair is just the x and y values that are connected through the equation. So doing that, we're going to use y equals kx. So I'm going to substitute 6 for y and 2 for x, and I'm going to put my k. I'm going to write it in the proper with the proper formatting. To isolate k, I'm going to divide. Oops, I wrote the wrong thing down. Let me erase that here and start over, because 6 equals 3k, not 2k. So I am going to divide both sides by 3 to isolate my constant k. The 3's cancel. 6 divided by 3 is 2, so my constant of proportionality is 2. So to write my general equation for this situation, I go back to my initial equation and substitute 2 for k. Now I have y equals 2x, and that is the general equation that models these values, that would model the values. So simply substitute an ordered pair into the general equation, solve for k, and then write the generalized equation. All right, our next example, example 12, states that force varies directly as current. Write an equation including k. So force varies directly as current. I'm going to use F for force, varies directly, and I'm just going to use k, and then I'm going to use I for current. So F equals k times I. Now if they had given us some values, we could have gone from here and figured out the different scenarios. So here, for each function on number 13, determine whether y varies directly with x or not, and if so, find the equation and the constant of using the constant of proportionality. So I have -6 and 2, 3 and 1, and 12 and 4. So how do we do this? Well, we simply substitute the different ordered pairs into the original equation and determine if the constant remains the same. So I have y equals kx, so I'm going to have -2 equals -6k, dividing both sides by -6. So k equals 1/3. Doing my next set, 1 equals 3k. K, once again, dividing both sides by 3 is 1/3. And then my last set, 4 equals 12k, dividing by 12. And when I simplify, I get 1/3. So, since my constant is the same in all the given ordered pairs, is it a direct variation? Yes, it is. And my equation is going to be y equals k, which we determined to be 1/3 of x. And that can be written y equals x divided by 3 is how you'd probably see that. Please pause the video and determine if B is a direct variation, and if so, what is the equation? When you're ready to check your work, please start the video again and see how you did. All right. Do we have a direct variation? I'm going to use y equals kx, so I have -2 equals -1k. Divide both sides by -1. My first constant for my first set of ordered pairs is 2. I'm going to go to my second set and I have 4 equals 3k. Divide both sides by 3. K equals 4/3. They're not the same, so that should tell you that it is not a direct variation, and I cannot have a generalized equation that models that situation for the data. Next, we're going to look at a couple examples. I'm going to do the first one, and then you're going to pause the video and you're going to do the next two and bring those answers to class with you when we meet next. So on 14, an electrical circuit has a fixed resistance so that the voltage E varies directly as the current. If the voltage is 115, when the current is 5 amps, find the equation that relates E and I. So that first sentence, voltage varies directly as current, tells me that E varies directly, means I'm going to have a constant of proportionality, and my current I. So if my voltage is 115, I'm going to substitute 115 in for my voltage. I've got 5 amps for my current, and then K for my constant of proportionality. I just substitute in the values for the variables. To isolate K, I'm going to divide both sides by 5, and I should have K equals 23. So writing my general equation, I take this number, 23, my solution, and I go up to my original equation. And the generalized equation is going to be E equals 23I. Now I can figure out the voltage and current for various situations as they arise. Please pause the video, complete questions 15 and 16, and bring those solutions with you to our next class. We won't be doing them here together. We'll work on them when we get back together. When you're ready, please continue with inverse variations.